So, tell me about these things. Are they geometric sequences?
Yes.
Some of them are. Should we just start at the top, or are there ones you want to start talking about first?
Top. Yeah.
Top left?
Yeah.
Okay. This guy?
A
Yes.
is
A is 2.
and R is 2.
Or
A is 2,
parentheses.
R is 2?
Yeah.
And that was a yes, correct?
Yes.
Yes.
Okay. How about the next one?
A is 1 and R is -5.
Okay, so A is 1, R is -5.
Yes.
So what would the next term be?
Positive.
Positive, good. And whatever 5 to the whatever is.
6
Yeah.
something.
625. How about this guy?
Yes. Plus 1. 1.
Ooh.
Can you do it?
I think
it's.
unless you can do
Or you have to do it with
No?
multiplication, right?
No, because geometric sequences are specifically multiplication.
Oh.
And you guys were seeing that this was what?
Addition.
Yeah, there's a really consistent addition, right? This is add 1, add 1, add 1.
It should really be in the definition.
Kind of
Yeah.
continue, right?
Like,
Yeah, so maybe we should give this give this thing an idea.
No.
You guys, does anybody know the name for this? There is one that you maybe should have learned in Algebra 1.
Sequence.
Yeah, it is a sequence.
Oh.
It's a close. So close. That's what we would call it if we were being nice to you.
Oh.
But apparently we're jerks. So we're going to call it an arithmetic sequence.
No.
Great.
Which maybe you learned in Algebra 1 or maybe you didn't. You didn't if you took Algebra 1 from me. Because this is where I like to talk about sequences. So we talk about geometric sequences, which are multiplication, and arithmetic sequences, which are addition.
Addition. Okay.
It's so strange. I don't know.
Would arithmetic be different
you
than
would think
subtracting?
it's.
Yeah, so would an arithmetic sequence allow subtraction?
I think so, because addition and subtraction are the opposite of each other.
Yes. Is there one of these that's division?
Yes.
You guys see that?
Which one?
Yeah.
That one.
That one. Oh,
This one's division by 2 at each stage, right? Which is the same thing as...
Multiply by half.
Oh, cool. So we actually know that one. We just answered part of that. We just said the R for this one was a half. What's the A while we're at it?
1.
1. And the answer was yes?
Yes.
You guys cool with that?
Yeah.
Okay. Is there another arithmetic sequence up here?
Yeah, the one right
Yeah,
above
4,
it.
8, 12, 16.
Ah, okay. So this one we would say no, it's not a geometric sequence.
Arithmetic.
It's arithmetic. Okay. And this one starts at 4 and adds 4, right? Is there another one that's arithmetic?
Would it be like the 1 and 0, or?
Or the
It
zero.
could be
Zero.
the zeros.
Could be the zero.
Well, you could subtract, yeah.
That could be like.
So it could be the zeros, right?
Addition,
That could be both.
Let's forget the zeros for a moment. I want you guys to, do you all see this one?
Yeah.
Do you think this one's arithmetic?
No. I think.
Kinda,
Yeah.
right?
On the
What's
bottom
the
one.
what's the thing you do to get between items in this? Like to get from here to there, what do?
You add a 1.
You add 1, but you
Add one.
do it to the
Denominator.
to
So you have
the
to
bottom
multiply.
of the fraction.
Wait.
So
No, seriously.
this one's actually really bizarre. It's not geometric, right? Because to multiply between these two, my R would have to be 1/2, and then this one would be a quarter, not a third, right? So it's not geometric.
Yeah.
So I can write down no here. It's not geometric.
What is it? Is it arithmetic? But.
So to be arithmetic, from here to here, I'd what? Take away a half. So the next one would be take away a half, which would get me to 0, not a third.
So it's neither?
So it's not geometric. It's also not arithmetic. This one is so fundamentally bizarre that we gave it its own name. Of course. And this one's weird because the other two names we have are for sets of sequences, right? Like we have the geometric sequences that are all the things that are made by starting somewhere and multiplying. We have the arithmetic sequences that are all the sequences that are made by starting somewhere and adding. This one is really this is the one harmonic sequence.
It seems so harmonic.
Harmonic sequence.
Okay? This guy is the harmonic sequence.
So this is the only one that's like that.
This is the one that gets that name.
It's unique.
Cool? So there aren't harmonic sequences, there's this one.
Nice.
You guys cool with that? Why? Really good question for a totally different day. So for right now, this one is something that I would like you to acknowledge as a curiosity of naming, basically. When we get to higher things where we start adding up sequences and things, this one will be a really pathological, horrible thing that'll happen. And it will seem like it shouldn't exist. It's such a nasty little thing that we gave it its own name so we could just remind people that it actually does exist.
Why
Cool?
didn't they call it the demonic sequence?
They probably should have, but apparently it has some use in music. I'm tone deaf.
It doesn't
Oh,
flow,
yeah,
though,
harmonics.
or does it? It does
It's like
flow.
special.
Yeah, it's somehow special in music. I don't know. So, let's see. How about this guy? That was our next one that we hadn't answered,
A
right?
is 1,
A
R is
one.
3.
3, 9.
A is 1 and R is 3.
So I was saying yes and green, right?
Yes.
So yes,
Purple.
A is and
Distinguish
R
those.
is. A is 1 and R is 3. Okay. How about one with zeros?
I say yes. Multiple.
No.
R is
I think it
0.
is.
So if I was to write this down, right?
Yeah.
Like my first attempt would just be to say, okay, what's A and what's R and does it work?
A is 1.
A is 1, R is 0.
A is 1, R is 0,
And it works.
Oh.
and it works, right? So yes. Okay, see that? How about this guy with zeros?
Sure.
Yes,
A is
it works.
0.
So A is definitely 0, right?
R could be missing.
R is all real numbers.
R could be really whatever, right? Which feels wrong.
Because you also do it could also be an additive one where you're just adding, subtracting
Right.
0.
Yeah, you guys see that? This could also be an arithmetic sequence where we start with 0 and add 0 at each stage.
Yeah.
You guys see that? So yeah, really this could be both.
No.
And it's not the harmonic sequence because it's not that thing, right? You guys see that? Even if I did this, right, where I cover up the 1, that thing's not the harmonic sequence anymore. It's
Wow.
part of the harmonic sequence. You guys see that? That one's really special. It really is just
Also, it
that
has
one.
to start at 1 and go
Well,
that
does-
way.
does
Yeah,
it
this
just
is
keep
the
adding?
harmonic sequence with a capital T.
Does it just
That's
keep
the
adding
one.
1 forever to the bottom?
Oh yeah, yeah,
Yeah,
yeah.
okay.
Continue in that pattern. So this guy is, yeah, maybe, and also it's an arithmetic sequence. How about this guy with 2's that you guys thought of?
No.
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 Arithmetic?
A is 2, R is 1.
Yeah. So it could be both
Yeah.
again.
1.
Yep.
But could it be plus 0?
Yeah, so we could think about this both as an arithmetic sequence where we add 0, or a geometric sequence where we multiply by 1.
So it's again both.
So this is yes, and this one actually is for sure both, right?
Okay. Yeah.
There's no special name for both of them together the same way, is it just
No, because it
You
only
say
happens
multiple.
with these.
Oh, okay.
Yeah, the only ones that are going to be the same are the ones that are the same thing every time. And then you can either think about that as multiplication by 1 or add 0. You guys see that? Those are a little bit funky. Cool?
Cool.
All right. So this is a good first set of examples. Should we do some more examples?
Yeah.
Is this even a
Yeah, is
Okay.
this a chapter or is this?
Yeah.